Okay, so this problem, if you make a mistake on a torque problem, it's usually because you don't get the distances right. I mean, most people know it's going to be the multiplying a force times a distance, but if any of those distances are wrong, you won't get the right answers. You want to do whatever it takes to make sure that you get the correct distances. So what I would do in this problem is, first of all, this line that I'm drawing will represent the tray from one end of the tray to the other end. And I know that the tray has a full length of 26 centimeters because that's the beginning of the tray and then that is the end of the tray. So what I want to do is, rather than have the numbers that they have here, I want like the distance from there to there, the distance from there to there, the distance to the center of the tray, to the plate, to the cup, so I have all the individual distances along the way. So the one thing that's not on here, they have all of these lengths, but they don't have the tray. But it does say in the problem that the tray itself is 0.30 kilograms and its center of gravity is located at its geometric center. Well, if this thing is 26 centimeters, then I know 13 centimeters from that side, from the left side, that's where I'm going to make the arrow to represent that. Another thing about this problem, notice all of these are masses, they're not forces. And they're asking for the force from the fingers and the force from the thumb. Well, what you can do is you can convert all of these numbers here into newtons, or you can just wait until the end. Like I can get my force, I can get the force from the fingers and the force from the thumbs in terms of mass, which really isn't a force. But then at the end, if I just multiply by 9.8, it will become a force. Because every one of these numbers would simply be, if I wanted the cup of coffee in newtons, I would multiply by 9.8. If I want the tray's weight, it would be 0.30 kilograms. If I want the plate of food in newtons, I would multiply by 9.8. So all of these are, you simply multiply by 9.8. So rather than do 3 of them before I even get started, I'm just going to wait till the end. So what I'm going to put in here is now the thumb pushes down. The thumb and the fingers work together to create actually a counterclockwise torque to cancel out all of these things that are making it go clockwise, because I've got all these down forces to the right of whatever I call my pivot point, so they're all making it go clockwise. So my thumb and my fingers have to produce the opposing torque. So I'm going to have a force down here that's going to represent the thumb. Then I'm going to have the force from the fingers there. Then I'm going to have right in the middle, I'm going to have the weight of the force from the tray, the weight of the tray. And then I'm going to have the plate of food. Plate of food is a pretty big number, so I'm going to make that a little bigger. And then the cup is over here. I may not have drawn those all to scale, but I'm going to put the right numbers in. So now I'm going to say that from here to here is 5 centimeters. And they're all 0.0, so just to give myself room, I'm just going to put 5 centimeters, not 5.0. So that's going to be 5 centimeters. And then from here, from the end of the tray to the fingers is 8. So if that's 5, then what am I going to put right in here? 3. So that's going to be 3 centimeters right there. Now the next one is the plate of food. So what do you think this distance is right there? Not 7, because 7 is to the plate. 7 is to the plate of food. I need it to this is to the tray. The tray is the one that's not on here. Like I don't see any distances here. Like I don't have an arrow here in the middle, and I don't have what the distance is from the middle of the tray to there, but I know how long the whole tray is. So if the whole tray is 26 centimeters, then how far is it to the tray's center of mass? 13. So if it's 13, then what will be my value for this right here? 5. All right, because 5 plus 3 plus 5 gets me to 13. And then what's the next distance? 2, because that is 15, to the tray is 13, so 15 minus 13 gives me 2 centimeters right there. And then, so actually it's right on the picture for the next distance, because it says from the plate to the cup is 9, so that's going to be 9 centimeters right there. And then there actually are, if you add these all up, well, from there to there is 24, and from there to there is 26, so this little distance right there would be what? 2. And if I add them all up by putting them all in, they should add up to 26, because that's the full length. So 5 plus 3 is 8, plus 5 is 13, plus 2 is 15, plus 9 is 24, plus 2 is 26. So that's the way I would suggest you do it, because you'll be less likely to make mistakes on the distance. Now, if we want to figure out what the force is on the fingers, then we will make the thumb, well, let me label these things here. I'm going to have that this is the thumb, this is the fingers. This amount right here is the tray, so that's 0.30 kilograms. The next thing is the plate of food, which is 1.50 kilograms. And the cup is 0.28 kilograms. All right. Now that we have that, we need, if I want to solve for the fingers first, I have 2 unknowns in this problem. I don't know that, and I don't know that. So if I want to solve for this, I make that the pivot point. If I want to solve for this, I'll make that the pivot point. So the fingers is the first one there. So I'm going to make the thumb my pivot point. And so I'm going to sum up the torques. I know they have to add up to 0 because this thing is not rotating. Okay, it's stable. So I'm going to sum up my torques. And the first one is this one making it go clockwise or counterclockwise. If that's my pivot point, is this one making it go clockwise or counterclockwise? Counterclockwise. So counterclockwise means plus. So it's going to be plus the fingers times its distance to the pivot point, which is 3 centimeters. All of the other ones are down arrows to the right of the pivot point. So every one of these is going to make it go clockwise. This one, clockwise. This one, clockwise. So they're all making it go clockwise, so they're all going to be negative. So I'm going to put in negative 0.30 kilograms times its distance to the pivot point is 5 plus 3. So it's going to be 8 centimeters. Minus 1.50 kilograms times its distance to the pivot point. So it's going to be 3 plus 5 plus 2. That's going to be 10 centimeters. And the last one is 0.28 kilograms times its distance to the pivot point, which is going to be 3 plus 5 is 8, plus 2 is 10, plus 9 is 19. So that's going to be 19 centimeters. And this whole thing has to add up to 0. And then I'm just going to move these 3 terms to the other side and divide by 3, and I'll have the answer. So F is going to equal, when these 3 go to the other side, they're all going to be positive because they're negative on the left side. So it's going to be 0.30 kilograms times 8 centimeters plus 1.50 kilograms times 10 centimeters plus 0.28 kilograms times 19 centimeters. And that whole thing is going to be divided by 3 centimeters. Now, if you want to get the answer right away for the force, we can take this whole thing, because the centimeters are all going to cancel out, but I'll still have kilograms. So I want it as a force, so take this whole thing and multiply it by 9.8 meters per second squared. That way my answer will actually be a force. It won't have my answer in units of kilograms. So if we solve that, what number did I give you for that? 74.2? I didn't? Okay, so the force is 74.2 on the fingers. Shut this off before I run out of time.